All right, ladies and gentlemen, welcome everybody. Thank you. And on behalf of everyone here, I'd like to thank you all for coming out to the second annual World Conference here at Nagios. Up next, we're going to have Alex Solomon, co-founder and CEO of PagerDuty. Why don't you go ahead, give him a big round of applause here.
Thank you. Hi guys. I'm Alex, and I'm here to talk to you today about managing your heroes. So the people aspect of monitoring. And it's a focus on dealing with outages and failures, as well as the kind of human element to that. So by way of introduction, I am one of the co-founders and CEO of PagerDuty. PagerDuty, we have a product also called PagerDuty, which does on-call management and alerting for IT ops. So kind of handles alerting and when some plugs into your monitoring tools. When something goes wrong, like your servers or websites or anything like that go down, we will alert the right person so they can fix the problem. We also handle on-call scheduling and escalation and stuff like that. And I've been working on this for just about 3.5 years, and I've been thinking about on-call procedures and best practices for even longer than that. So before that, I worked for a company called Intersect, building e-commerce websites. And before that, I worked at Amazon.com over in Seattle as a software engineer. This is where I was first introduced to on-call, actually. What Amazon does is they actually put all of their engineers on call. You have to wear a pager on your belt. It's called being on PagerDuty, unsurprisingly. Yeah, that's where we kind of got the idea for PagerDuty as well. So I like to, before we just dive right into it, I'd like to go over a few quick definitions. One of which, I'm sure you guys are already familiar with a bunch of these, but one of which is a service level agreement, or SLA. This is a contract between you or your company and your customers or users, which defines the level of availability that you're going to offer to your customers. It's typically defined in terms of an uptime guarantee. For example, 99.9% uptime guarantee. That means you need to be up that amount of time, or you can only go down 0.1% of the time. Another one of these is mean time to resolution, MTTR. This is actually a very, very important ops metric. It kind of defines how quickly you resolve outages from the time that they are detected to the time they are fully fixed on average. And closely related to that is mean time to response, which is how quickly your team or your on-call people respond to outages. Mean time to response is actually a subset of mean time to resolution. So if I can give you an analogy, imagine your building's on fire and you just call 911. Your response time, or the response time of the firefighters, is measured from the time that you made the call till the time that they actually show up at your doorstep. And the resolution time is the total time from the 911 call until they actually put out the fire. And then last but not least, we have mean time between failures. This gives you a sense of how frequently outages or failures happen. So if you have an MTBF of 1 month, that means that on average you go down once a month. So let's talk a little bit about outages. Can we prevent them? As you know, an ounce of prevention is worth a pound of cure and all that. So there's various things you can do to prevent outages. One of which is look for single points of failure. Look for single points of failure in your infrastructure. So, and then to fix that, you have to add or engineer your systems such that they're redundant. Let me give you a simple example. Let's say you have a MySQL database. If you're just running a simple one-server setup with just the one master database, that's a single point of failure. If it goes down, what do? Well, you have to restore from backup, or try to get the server back up or something like that. You're kind of screwed. So what you want to do to eliminate that is examine how much downtime is acceptable for you, and also look at whether it's okay to have some data loss or not, and then set up a replica. That's one common scenario. So if you're okay with 10 to 20 minutes of downtime, do a replica, and then set up a process whereby you promote that replica to the master and you do a flip. If your uptime requirements are actually more stringent, kind of like in the 1 to 2 minute range, which is the case for us, that means you can't use MySQL in the first place. And another cause of outages is big, complex, monolithic systems. By this I mean systems that are very tightly coupled, where you change one little thing here and then something breaks over here. And part of the reason I bring this up is because PagerDuty started as a big monolithic system on top of MySQL. And we've ended up with cases where we change something in the billing system and it would break reporting. So we're now working on taking that big system and dividing it into components and moving to a service-oriented architecture. So we're taking our system and breaking it up into services, which are independent stacks, which talk to each other via APIs. This is a pretty common practice, actually. Amazon does this, Netflix does it as well. For example, here is a diagram of Netflix's distributed SOA architecture. So each one of those boxes is a service, and all the lines are how they talk to each other. And another factor of preventing outages, or of cause of outages, is change. So systems that change a lot generally have more problems or failures. Conversely, systems that rarely change or never change it can be made to be fairly reliable. So think the telephone network. It actually achieves 5 nines reliability, 99.999% uptime. Unfortunately, there's not much you can do about this. I mean, presumably, you're developing a business. You're building new stuff. You have customers who want new features. So you have to push the envelope forward. You can't just freeze your system at one point in time and say, okay, that's it. We're not changing it anymore. So ultimately, while there are many things you can do to kind of reduce outages and reduce downtime, failures are just going to be a common fact of life, and they will happen. So you have to start thinking about how to deal with them, how to mitigate them, and how to quickly respond to them instead of kind of burying your head in the sand and saying, we will never have any outages. So this brings me to the failure life cycle. This starts with monitoring at the top. Actually, I feel that as a community, we put a lot of emphasis on monitoring. We talk about monitoring large-scale infrastructures. We talk a lot about metrics and dashboards and correlating failures together. And this is really good. However, it feels at times like we don't consider the rest of the life cycle enough, like how to deal with outages when they happen. And this is kind of the reason why I'm doing this talk. So at a high level, the failure lifecycle is actually pretty simple. You start with monitoring. Your monitoring tools look for various failures across your infrastructure. At some point, a failure will occur and will be detected by monitoring, and an alert will be kicked off to your ops engineers. The ops engineers will investigate the issue, and they will eventually fix it after much trial and tribulation. Now, a good ops or engineering team will have an extra very critical step in this pipeline. This is called the root cause analysis step. So you do this after the problem is fixed, and you start digging deep, and it's a little bit like detective work to figure out why the problem happened in the first place. And then, of course, after you do your analysis, there should be a critical feedback loop such that you implement improvements in each one of the stages. If your monitoring was broken in some way, you improve it. If your alerting processes or your alerting systems need some work, you improve that as well. You improve each one of the steps and processes as well. It's not just tools, it's also about the processes. So I can go into a little bit of an example here. Let's say you're running a web application and it goes down. So your monitoring detects it, of course, and it kicks out an alert to the ops engineer. The engineer gets woken up and goes and starts debugging the problem. He sees, oh, it's the primary database is down. Okay, let's do a flip to the backup. So now, after a while, the problem is finally fixed. The backup is now the primary, and it's time, during the day, not in the middle of the night, to do the root cause analysis. So in this example, let's say the root cause analysis shows that the database primary was out of disk space. So what's the problem? Well, number one, your monitoring system didn't detect that. So we need to go back and start implementing some disk-based monitors across not just the database server, but all of our servers. I mean, we made the mistake once. We don't want to make it for other servers. At the alert stage,